Here is the test that generates machine mode software interrupts. The test is broken down into 4 simple steps. The first step is to set up the exception handler. Here we see on line 11, the base address of the handler is loaded in the T1 register using the load address sudo instruction. The least significant bit of T1 register is then set. The test then writes the T1 value into the emptyvec CSR using the CSR write instruction. This code sequence sets up the base field of the emptyvec CSR to point to the handler base address and the addressing mode field to be vectored. The next step is to enable interrupts globally in machine mode. To do this, the test sets up the MIE bit in the mStatus CSR. At the completion of the instruction on line 23, interrupts are globally enabled in machine mode. Step 3 is to enable the recognition of machine mode software interrupts. To accomplish this, the test writes into the MSIE bit of the MIE CSR. MSIE stands for Machine Software Interrupt Enable, and it occupies a bit position of 3 in the MIE CSR. The final step is to generate the software interrupt by writing to clint. The clint lives at memory address of 0200 and is defined in the platform.h of the Spike source code. Here on line 36, the clint base address is loaded in the T0 register. T1 is loaded with a value of 1, and the store on line 38 stores the value of 1 into the clint base address. This sets the software interrupt pending for hard 0. At the completion of this store, a software interrupt is pending and the PC is redirected to the handler. In the handler, the entry point is at byte 12. This is because the emptyvec addressing mode is set to vector mode and the machine mode software interrupt has a code of 3, which causes the entry point of the handler to be at byte 12. Here we see that in byte 12, the main handler code simply jumps to the routine that handles machine mode software interrupts. In the routine that handles the machine mode software interrupts, the MCOS register is read first, followed by the MEPC CSR. Once this information is captured, the code writes a value of 0 to the address in T0. Recall that T0 still contains the clint base address. Writing a 0 to that address clears the pending software interrupt. Once the software interrupt is cleared, the value in the MEPC is incremented by 4 and the test handler executes mret to exit out of the handler. When the mret instruction is executed, the control transfers to the PC after the MEPC CSR. The MEPC CSR originally contained the PC that was pointing to this infinite loop, and the handler incremented that to the next PC So at the completion of MRET, the test control passes to the test end section, which triggers the normal spike termination sequence. In the next video, we will run this test and inspect the spike output.